Hello everyone, this is Sir-Fredrick on air. In this video, we are going to talk about criteria of purity. Picture me, I'm having two beakers. The first one, there's water there. There's water. I'm having H2O in this beaker. And the second beaker, I'm having also water there, but unfortunately my brother at home dropped some sand in it, so it contains apart from water, it contains other substance. Okay. Okay, so yeah, just like that. Okay, so here we have sand and water. Okay, so the question is this: what is the difference between the substance in A, which is only water, and the substance in B, which is sand and water? What is the difference? Probably others will say in beaker A there is just only water, fine, and others will suggest in B is sand and water. So in science, the substance that exists in its one element is called a pure substance. So in this case, beaker A contains water only. So, and it's just only water, it's a pure substance. And in beaker B, there is sand and water, which is a mixture. So the difference between these two beakers is that in A, it's a pure substance. In B, it's an impure substance or a mixture. That's it. Okay. So apart from that, so this one is pure, this one is pure, this one is an impure substance. Okay. Okay. Now the question will lies again. Let me create some space. The question will lies. Okay. What is the difference between a pure substance and a mixed or an impure substance? So the pure substance, pure substance, a pure substance, the pure substance is, the difference is that a pure substance contains only one element, while an impure substance contains more than one element. That's the second one, the first one. The second one is that a pure substance as 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 sharp sharp or exactly melting point, which is MP, and exactly boiling point, which is BP. That's the first. The second difference. While an impure substance, of course, its melting point or boiling point melts, it's over the range of temperature. So, an impure substance, impure, we said the pure substance has a sharp or exact boiling point or melting point, and impure, while an impure melts over the range of temperatures. So meaning an impure substance does not have an exact melting point or boiling point. It can be over the range of temperature, which can be maybe from 1 to 4 degrees Celsius, or maybe other temperatures, maybe 10 to 11. That is not an exact or sharp melting point or boiling point. That's the difference. Difference number 2. Another difference that we can deduce is that an impure substance has got as an impure substance has a low boiling point, lower boiling point BP, but higher BP. Okay, so that's it. That is when we want to talk about the pure and impure. So what we said, like we said before, a pure substance, one first difference, a pure substance has only one element in it, while impure substance contains more than one element. The second one is we say that a pure substance has got a sharp or exact melting point or boiling point, while an impure substance boils or melt over the range of temperatures. Okay, now let's talk about how we can differentiate a pure substance if you were given a data on the graph. So actually we'll draw something. We have here a graph. Okay, here it's temperature in degrees Celsius. Here it's time in seconds. Okay, so this is an ice block. You take an ice block from the refrigerator, you expose it to the sunlight. What will happen? It will start melting. So observe, it will start melting. Okay, just like that. So if that is the ice that you had, you exposed on the sun, so here will be point A, this will be point B, this will be point C, point D, E, and F. Okay, so if this substance were exposed to the temperature above zero, it will start melting. So here you'll find that it will start melting until it reaches its specific melting point. So for example, let's take a reference to this substance that is melting at zero. As it was melting. So if this was solid, here it will melt to what? To liquid until it achieves its gaseous state. Until it reaches its gaseous state. Okay. So if you've seen, it has just on the sharp, you can able to tell that this substance was its melting point was at 0. So this is melting point, and maybe after some times when you increase the temperature this side, because it will start acquiring its liquid state. Again, when you supply more heat, it will reach a point at which it will start, the all substance will turn into gas. The all substance will turn into gas. So this side, let's take a reference. We have a 0, we have 100 degrees. So here you're going to have a boiling point. This is the boiling point. So you can able to tell that this substance at the boiling point of 100 degrees. So until it reaches. Here on the same graph, they can put some questions more. So some questions such as what is the process was taking place from section BC, or what was the substance in section CD. You just have to take care and you remember those information you learned during the state change of matter. Actually, that goes again. Here we can ask you another question by saying, what was the substance at BC? The substance at BC, since solid was melting to liquid, it does not just melt as from solid, it definitely turn into liquid just like that. No, if you take an undertone observation, when you take out a container which is in ice, you put on the sunlight, it will start melting slowly with partly solid, ice, and liquid. So here you decide that melting point or melting, you're going to have liquid, you're going to have solid and liquid, solid and liquid in this state. Okay. There, as you continue supplying heat, DE reaches a boiling point. Here you're going to have part of liquid and part of gas. So here it will be liquid and gas. That would be the mixture per DE. Okay, that's how it goes. So this is how we can able to tell that this substance which was passing through, which was tabulated on the graph, was a pure substance, because it has what we said, it has a pure, it has an exactly boiling point which is there, and the exact melting point which was there, somewhere there. Okay, now let's have a graph which is showing an impure substance. This graph which is showing impure substance. This temperature in degrees Celsius, time in second. So you are going to have a graph which is like that. So if I were to ask you what is the melting point of this one, you can't tell because you will not see anything. Maybe the melting point started from this side up to there. If you look at the temperature, maybe here it was somewhere. The 0 was here. This was the 0. Okay, the 0 was there. So meaning this one started out in this side up to there, which is maybe from negative whatever, negative 1, whatever, up to somewhere 2, positive 2, which is not the exact melting point. So MP is not exactly. again, if you can take a look here. If this is the, I don't know if it could be a BP, which is boiling point, which is not exactly as it is. So that is the graph for impure substance. Okay, so you can have a curve like graph, which is showing not exact melting point and boiling point. Okay, now let's talk about the importance of purity. Importance of purity substance. Purity in the substance is very important in the following areas. So we say importance can be in foodstuffs. The purity of substance will be very pure in foodstuffs. A food should be in its pure form so that it cannot bring challenges or defects in health of animals. So in foodstuffs, apart from that, in medicine, in the manufacture of medicine, drugs should be very pure. So that it can be able to be cured when you take drugs, when you take a medicine. Not only that, and also in industry, such as in the manufacture of drinks. So before they release a drink for human consumption, they have to test its purity. So these three sectors, the pure substance or the purity of the substance is important in foodstuffs, medicine, drinks. So that the health of animals cannot be disturbed or cannot be tampered with. So what we are saying, the purity in substance such as foodstuffs, medicine, drinks is very important because impurities can affect the health of animals. Examples of animals is you and me, even other things. Sometimes I can see people taking a dog to the clinic. That is an animal, so they have to give it a pure substance in medicine. Okay. Apart from that, the purity in the manufacture of computers should be there. For example, a computer microchip. Should be in its purest form. Should be in its purest form. Okay, cell should be its purest form. So that it can work well. So if your computer or the phone is not having a purest microchip processor, it will not work well. So in the manufacture of computer, the computer microchip processor must be in its purest of silicon, or otherwise it will not work. So we discussed the importance of purity in the substance, the difference between pure substance and impure. So let me quickly summarize by going through on what we've learned today in this video clip. Okay, we said pure substance contains only one element, and impure contains more than one element, not only that, we also differentiate we differentiate pure substance and impure in this following. So pure substance has got sharp, as sharp, sharp or exact, exact, melting, MP, and boiling point, BP. While an impure substance melts, melts, melts over the range, over the range of temperature, over the range of temperatures, temperatures. And we also talked about another difference: an impure substance, impure substance has low, lower melting point, but higher, 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 higher BP, boiling point. Okay. We also talked about the differences, or not we also talked about the importance of this spirit. We said the importance is that in foodstuffs, the purity should be there in the substance, such as foodstuffs, medicine, drinks, or else the impurity can affect the health of the animals. Not only that, we said the importance of purity in the substance in the production or in the manufacture of computer microchip processor to be its purest silicon, or otherwise your computer or the phone will not work. Okay, join us in more videos. The next video will talk about the experimental techniques or method of separating mixtures. Thank you very much. It's Sir-Fredrick Explains.